Hello everyone, I'm Luna and I'm an astronomy undergraduate. My project is the detection of transients in J-VAR. So, to give you a bit of context, optical transients are super interesting objects in the sky. It can be faraway supernovas or faint dwarf nova outbursts, as well as eclipses and comets and so much more. In my project, I will be focusing on supernovas, which are basically powerful and luminous stellar explosions. In the image there's SN 1994D, and as you can see, supernovas can be as bright as their host galaxies. Another example is the Caracalla supernova. It is visible in the images on the lower right that in March it wasn't there, and in July suddenly there is a new bright object in the sky. These days, many wide field surveys are being carried out, and they're ideal to repeatedly observe the sky and discover new things. Two of these wide field surveys are J Plus and S Plus. They are twin projects dedicated to mapping the observable universe in the northern and southern hemisphere. JVAR is their ancillary project. The main science goal of JVAR is to detect variable sources, in particular transients. In the images, you can see the 80 centimeter telescope JAST and the observatory where the J Plus survey is being carried out, the Observatorio Astrofísico de Javalambre. In collaboration with UFRJ, I am exploring the use of differential imaging techniques to detect transient objects. The first step of what I do is to select the images according to the epoch. If you're not very familiar with the term, it just means from different dates. Images from December are from one epoch, and images from April are from another epoch. So I have to select and co-add them. If I have 3 images from December in a certain filter, I add them up and end up with only one. After that, I have to align the images from different epochs and subtract them from each other. So if an object is in both images, it will disappear from the final result, and only the changes in the sky will remain. That means that if an object is in only one image, I may have a supernova candidate, just like in the Caracalla example. To exemplify a bit more, on the right you can see a part of the co-added and aligned images from December and February in the G filter. On the left is the subtracted result. The white arrows indicate the subtraction of an object that was in both images, and in the bottom you can see a supernova candidate. It is in fact a supernova that was detected in the beginning of this year. Comparing the images on the right, you can spot the change in luminosity from December to February. But of course, the subtraction is not perfect, and not every object that remains is a supernova, so I have to reject the false detections. As you can see, there is a detection of an object that meets all the requirements but is not a supernova, and it's likely to be a satellite. Our goal is to not only identify the transient, but to provide a preliminary classification as well. The calibration allows us to convert the counts into a proper magnitude, and the light curve will allow us to see how the emission changes in time to try to classify the candidate. The ultimate goal is to have a software running semi-automatically to select the best candidates for a spectroscopy follow-up and to reject the false detections. And that's it. Thank you very much.